Today we will solve a few interesting sums on triangles which are of level 3. So let's get started. The first one says that if D is the midpoint of the hypotenuse AC of a right angle triangle ABC, then prove that BD is equal to half of AC. So this is our triangle ABC and B is the midpoint of AC, and we will mark accordingly. So before proving, we will construct a little bit. What we will do, we will extend or we will produce BD till E so that BD is equal to D, and then we will join E and C. Now if we consider the triangles ABD and ECD, so what we can see here is AD is equal to CD because it is given that D is the midpoint of the hypotenuse AC. Now BD is equal to ED. So BD is equal to ED. Why? Because as per our construction, we produced D or BD till E such that BD was equal to ED, and angle ADB is equal to angle EDC because they are vertically opposite angles. So what we can see here is between these two triangles we have side angle side congruency. So from the congruency of these two triangles where this side is equal to this side, these two angles are same, and this side is equal to this side angle side and side angle side, SAS congruency. So we can say that from those two congruent triangles, AB will be equal to EC and this angle BAD will be equal to ECD, this angle. Now from these two sides AB and EC, with respect to them, what we can see here or what we can say here is these two angles, since they are equal, so with respect to this AB and EC and also this AC line, what we can say here is that since these two angles look like alternate angles, so AB is parallel to EC, and with respect to those parallel lines, AC is the transversal. And now since AB is parallel to EC, that we have already proved, so we can say that angle ABC and angle ECB, these two angles will be what? With respect to those parallel lines, these two angles will be co-interior angles, and we know the summation of co-interior angles is 180 degree. Now as per the given problem statement, this ABC, this angle is right angle. So this angle ABC is a right angle. That means angle ECB, that angle will be also what? 180 minus 90. So that will be also 90 degree or right angle. Now if we consider these two triangles, triangle ABC and triangle ECB. So between these two triangles, what equal things we can see here is AB is equal to EC, that we have already proved, and also angle wise angle ABC is equal to angle ECB, and also BC is equal to BC, means for both the triangles BC is the common side. That means between these two triangles again we have side angle side and side angle side, SAS congruency. So if they are congruent triangles, then we can conclude that AC will be equal to B. Now as per our construction, D was the midpoint between B and E. So BD was equal to, or BD is equal to half of B. This is as per our construction, and we have already proved from congruency that AC is equal to B. That means in place of SB we can write AC. That means we can say that BD is equal to half of AC, and that we were supposed to prove. Now the second sum, in this sum what we can see is in a quadrilateral PQRS. So this is a quadrilateral PQRS where PQ is equal to RQ. So this is the quadrilateral PQRS where PQ is equal to RQ. P and U, these are the 2 points on PS and RS respectively, such that angles PQT, so this is the angle PQT and RQU, RQU, this is the angle. This angles and also angle TQS, so this angle, and angle UQS, so UQS, this angle. These two angles are equal, so these two pairs of angles are equal, and now we have to prove that QT is equal to QU. So QT is, this is the QT and this is QU, so these two sides are equal, that we have to prove. First we will consider these two triangles PQS and RQS. So between these two triangles, what are the parameters which are same? As per the problem statement, PQ is equal to RQ. So these two sides are same, and these two pairs of angles are same. So angle PQT, if we add this with angle, this just the adjacent angles TQS, then that will be equal to RQU, then the adjacent angles to this UQS. That means we can say angle PQS, this will be equal to angle RQS. And again, between these two triangles, QS is the common side, so QS equal to QS we can write. So what is the type of congruency? Here we have side, then this angle, then again this side. So side, angle, side congruency we have between these two triangles. And if it is so, then we can say that angle TSQ, this angle will be equal to angle RSQ. Next we will consider these two triangles, triangle TQS and triangle UQS. And between these two triangles, easily we can see the same equal parameters. So here angle TQS is equal to UQS, that was given. Then this side QS is the common side, and also this angle TSQ is equal to USQ. So that we have already proved. So here we have angle, side, and then angle, side, angle congruency between these two triangles. Now since these two triangles are congruent triangles, now we can easily conclude that QT will be equal to QU, and that's what we were supposed to prove. Now the next sum. In this sum and in this figure, where we can see both are isosceles triangles, both are means triangle ABC and triangle DBC. These two triangles are isosceles triangles, and then we have to prove that triangles ABD and triangle ACD are congruent. Secondly, we have to prove that AP, this side, bisects angle A. Angle A means BAC, and also angle D means BDC. And then in the third part, we have to prove that AP is the perpendicular bisector of BC. So perpendicular as well as bisector of BC. So we have to, bisector of BC means we have to prove that this part and this part are equal to each other, and perpendicular means this angle and this angle both are equal and both are having 90 degree angle value. Now if we consider this triangle, the first part ABD and ACD, then what we can see here, that since both the triangles are isosceles triangles, so AB will be equal to AC, and also from this triangle, the smaller triangle, BD will be equal to CD, and also AD, this side is the common side. So here all the sides means here we have side, side, and side congruency. So now since these two triangles are congruent triangles, so we can say that BAD, this angle, will be equal to CAD, right? These two angles will be same, and at the same time this angle ADB, this angle also will be equal to ADB, will be equal to ADC. Now with respect to this side AP, on the left side we can say we have this straight angle 180 degree, and these two angles ADP and also BDP, these two form linear pair, and on the right side also ADC and PDC, these two also form a linear pair. So these two angles, the upper angles, since they are same, so these two angles means rest of the angles will be also equal. And since these two angles BAD and CAD, these two angles are same, so we can say this side AD or maybe AP, this side bisects this angle BAC or angle A. So this AP is the angle bisector of angle A, and at the same time this BDP is equal to CDP. So again we can say AP is the angle bisector for which angle? BDC, or straightforward we can say angle D. So first two parts are already have been proved, and then the third part we have to prove AP is the perpendicular bisector of BC, and for that we will consider triangle BDP and CDP. Now from these two triangles what we can see is BD is equal to CD, because this is an isosceles triangle. So these two sides are equal, and also we have already proved that BDP, this angle, is equal to CDP, and also we can see that DP is the common side. So what congruency we can prove here? We can establish BD is equal to side and then this angle and then this side. So side, angle, side, and here side, angle, side. So between these two triangles we have SAS congruency. And since now these two triangles are congruent triangles, so we can say that BP will be equal to CP, and if these two parts are equal, then we can say P is the midpoint of BC. So AP is the bisector for BC or of BC, and also we can say that this angle APB is equal to this angle APC. So this is also perpendicular, means these two angles are same and also 90°, and that's why AP we can say is the perpendicular bisector of BC. Now the next sum. In this sum, what is given is a point O is taken inside an equilateral four-sided figure. So first let's draw that equilateral four-sided figure. So this is an equilateral four-sided figure where O is taken inside that figure. So O is that point. Now ABCD is that quadrilateral, and such that it distances from the angular points D and B. D and B are equal. So the distance of O, this point, from the points D and B are equal. So this side is equal to this side, and so that AO and OC are in one and same straight line, OA and OC. That means we have to prove that summation of these two angles are 180°, and then only we can prove that this angle will be a straight angle, or we can say AOC is a straight line. Now we can consider any pairs, means either these two angles, these two linear pair, or we can consider these two linear pair, and from there we have to prove that this angle is a straight angle. So we will consider these two angles BOC and BOA. Now if we add them, BOC, what we can see, this is the angle with respect to AOB, this triangle AOB. This BOC is the exterior angle, and that will be equal to summation of the opposite interior angles, right? This is an important property of triangle, and for this triangle BOA, this is also will be an exterior angle with respect to this triangle BOC, and that triangle will be again, that exterior angle will be again equal to the summation of the opposite interior angles. So that's what we will be writing next. So with respect to this angle BOC, this is the summation of these two angles. That's what has been written, OBA plus BAO. And with respect to this angle BOA, means this angle BOA, this will be equal to the summation of these two angles CBO or OBC plus this angle BCO. Now we can rearrange these angles, like angle BAO. So BAO, this is an angle, and BCO, this is an angle, and we are adding these two angles. So these two angles will form which angle? CBA or ABC. So BAO, that angle is equal to, means we can write this way, BAC, and for BCO, it means this angle is BCA, and when we are adding these two angles, that is forming the larger angle, which is ABC. Now these three angles are angles of what? These three angles are angles of this triangle ABC, And now we know this is another property of triangle, that for any triangle the summation of all the interior angles is always 180 degree. That means summation of these three angles will be 180 degree. And if it is 180 degree, that means we can also say the summation of these two angles is also 180 degree. That means this is a straight angle, and or we can say that AOC is a straight line. So we can say AO and OC, these two are in one and same straight line. So hence proved. Now the next sum. Here we have been given a right angle triangle ABC, right angle at C. So this is the triangle, and M is the midpoint of the hypotenuse AB. So this is the complete figure where ABC is the right angle triangle, which is C is the right angle, and then M is the midpoint of the hypotenuse AB. C is joined to M and produced to D such that DM is equal to CM, and point D is joined to B so that angles DBC means angle DBC, this angle, and angle ACB, this angle, these two angles are equal, and also CM is equal to half of AB. Now this sum is exactly similar to the sum number 1. So first you understand the solution of sum number 1 and then you try to solve this one by yourself. So this much was for today. See you in the next class. Till then, stay safe and stay healthy. Thank you.